Hello friends. So I've just now created during this weekend a mini project that is for the structured scenario generation. And in this the technology that I'll be using will be LangGraph. Along with that I'll be using some workflows, and inside the workflows I'll be creating the nodes and the edges. So the main idea of this is to solve a scenario generation problem in which we're going to prompt an LLM by a sample scenario, like with respect to autonomous driving, and we're going to have the generator node make the make the scenario, and the validator node should be able to check the authenticity and whether that the values from the generator node is correct or not. So one of the main um, key points here is that it is it will autocorrect based upon whether it's inside the bounds, and also include some human approval steps. So this is the graph workflow. So first the human will give the prompt to an LLM, and then this will go to generator node, and from there the validator node will check whether it is following some certain rules, and if not it's going to give some of the retries with the feedback like what is the previous error. So here we're going to put a maximum 3 retries. After this we're going to go for that human approval gate. In this we're going to have some checkpoints. So the model is saved once the human approves it, and after that we're going to create an output, or we're going to save the state. So first of all we're going to use a pydantic schema. So this pydantic schema is essential because we want the output in particular format, right? So with the help of this pydantic schema we're able to just define the exact output payload that should be expected from the LLM, and this we're using in the code using with structured output, and it's going to be in the JSON format. Another one is going to be the type tick state. So this is going to be for the scenario state. So this scenario state is something that would internally within the workflow, how it will decide how the various nodes and the edges are taking the data, like what parts of the data are they taking. So you can say like project workspace, like it is going to be a folder inside there multiple type of data is going to be fed. Nextly, this is telling you what is um, or the data inside the scenario state. So we're going to put the prompt like whatever the user is going to put, and the scenario JSONs. So this will hold some errors, like if the validator is showing some errors, so that errors will be passed to the generator, and how many times the generator has run, that also is going to kept here, and the approval rate, like whether the human has approved it or not. So this is like when we'll decide that the validation has some errors inside the generator nodes. This is the code for that. Um, Nextly, like inside the validation, how are we going to check whether a particular conditions has been met? That is that the generator is actually operating within that particular limit. So here we're going to use some conditional edge routing. So the reason why you're going to use the conditional edge routing is because we don't want the LLM to go into infinite API calls, which is going to drain our resources. So for that, we're going to keep a count, like the iteration count is going to be less than 3, and the validation errors are there. Only then we're going to call a generator. Else we're going to go for the human review. So this is how it's going to work in the human review. Basically going to use a keyword called function called interrupt. So this will pause the execution, and like only when the user has approved, only then, only then the the next process is going to happen. There is a memory saving. Until then, the graph is going to be completely frozen. So this is the execution life cycle. So first, we're going to do the basic creating the data using the schema data, and at the t is equal to 1 seconds, we're going to call the generator and the validator. And after that, when you have got that like the iteration is done, after that you're going to call it for the human review. Okay, so this is like how it's going to look. You're going to use app.stream for this purpose. And so why is this is important is because we need to understand that the validator is just a local Python function that is not calling any API calls. And we're also going to use like just a native LangGraph. In that we're going to use it a type dict. Later we can scale it to the MCP also. So that's model context protocol. So in the validation phase, we're going to call a external MCP validator server. So this is like a good hands-on before we go on to the details of the MCP part. So let's go for the code. So you can see here I've defined that scenario state, and inside the scenario state that we have this scenario schema, and the scenario schema is going to have some entities, right? Like it's going to be a car or like a person. So this entity is going to be defined by this data class. You can say that the entity should have an ID, or like what label it should be there, like a vehicle or a person, and the x and y coordinates inside a 2D frame. So this is just for downloading the Google Gemini, like the API call. So by doing this, so this is just the LLM, like how I'm correcting it, and I'm going to pass this structured the output, like how I want the LLM to process the data. Everything is there inside this scenario schema. So with the help of this, you can get a structured LLM output pertaining to this format, and then you're going to create a generator node. So in this generator node, we are going to giving a prompt. So based upon the prompt, it's going to create some JSON data. So in this JSON data, we're going to have, you know, the like the values, like what was the result of the iteration, and whether there's any change in the iteration count or not. So this is the chain. So inside this chain, you're going to put in the like the prompt template, or you can put the structured LLM. So and then we're going to create that result, and from this you can take the input as a prompt text. So whatever the prompt that put here, so that input you're going to take here. And here this is mainly for just understanding like what was the errors, and this errors again we can put it back to the LLM so that you can correct this data. So and inside this we're going to have a validator node. So in this validator node we're going to so in this validator node basically we're going to check whether the x and y coordinates are within 0 and 100. So this points has been generated here, right? It's going to be stored inside this scenario JSON, also the entities. So this is going to be extracted here, and the x and y coordinates for every entity is going to be checked against, whether it's following the within 0 to 100 rule or not. And then so this is for the route validation. So this will basically check whether we need to go for the human review or not, based upon like if there are any errors, and like we have reached the iteration limit. So this data also can get from this state.get. So as a result, I'll have to also say that um, Nextly, going to the human review part. So in this, we're going to use the interrupt format, and this is the message you're going to tell, please review and approve the generated scenario layout. And like whatever validation you had, if you had any errors, that will display the number of errors. And the scenario, like what is the what is the scenario the generator is working on, and errors, like what any errors that you have encountered till now. So in this, we're going to just prompt it inside this Colab notebook only, and based upon this, we're going to return these values that value has been approved or not. After that, um, we're going to create a graph here. So you're going to start a state graph and going to pass the state. So this is going to be scenario state. So scenario state, if you remember, is the folder. So that the project workspace inside which we want to create a state graph. So a workflow, we're going to add the nodes, that is the generator and the validator and the human reviewer. So nodes are, you can think as Python functions, and the edges decide from what, like how the information flows from one edge, from one node to another. So it start is the basic starting for the graph, and then we can go from the generator to the validator. And in this, we're going to add some conditional routing. So conditional routing is basically going to tell whether you want some particular function to execute or not. So this condition is going to come here. So it goes from generator to the human reviewer node, and at the end, like we can add this human reviewer node, and you can go for the end. And this checkpointer also is there. And at the end, like we can save this. Um, no, we can save this whatever the progress you've done. Set a checkpointer, and we can can compile this. So this is for that. Like every we're going to assign it to every thread ID, right? Like whatever state checkpoints we have. So this is going to be the phase one, which is going to run from the generator to the validator to the human reviewer. So, and this is how it's going to start. So we can see we can read the first generator. Can so ego car stopped for pedestrian description. The ego car is stopped, yielding to a pedestrian who is crossing the road in front of it, and the entities, like what are the entities are there and their coordinate values. So this is the first iteration, and this is the validator. That is validator doesn't have any errors, because if you have noticed that the x and y points are within the 0 to 100, and now the user is coming for the validation, like whether so that result is the ego car stop of pedestrian, and you need to a pedestrian who's crossing the road in front of it. And so these are the coordinates, and this is the ID, thread ID that we are having. So we're going to put you approve the scenario, you can put yes. And so that's it for the first scenario. So remember that the next scenario only handle when, because if anything is going wrong. So this is mainly for the visualization part. So this is the matplotlib, and whatever the values we are getting from the app inside that config file, right? So inside the config file, you're going to extract that values, and from that you're going to get a scenario JSON, and that values you're going to pass it, and it's going to display it in this format. So you can see it's coming like this is the ego vehicle and it stopped before the pedestrian. So I think it is an interesting project. From my side, it was my like first main project for the LangGraph. So let's try to change it once. The prompt. Yeah. Okay. So you can see the prompts have changed, and based upon that we can get that the we want to give that output. The values have changed, right? So this is it from my side.